Well, my name is Professor Viren Pereira and today I am going to tell you about source conversion. Now, how many types of sources are there in an electric circuit? The first source is your voltage source and the second source is your current source. Your voltage source is represented by this and your current source is represented by this. If you see, your voltage source has a positive and a negative. Now, as I have told you last time as well, current always flows from positive to negative. So it will flow from positive and then go to negative. So it will move from positive and then return back to negative. So this is your voltage sign. Now, your current sign on the other hand represents a circle with an arrow symbol. Now, this arrow symbol basically represents the direction of that current. So, if we have a voltage source here which has positive and negative, as I told you, current moves from positive and then goes to negative. So, the current direction will be upwards. So, it will move from down to top. That's why the same direction is given here. So, if this is positive and this is negative, obviously I can say this is positive and this is negative. If this was reversed, then this also would be reversed. But now the question lies how we can switch over from a voltage source to a current source. So to understand it better, we will take a small example wherein you have a voltage source of 5 volts. Say this is your V1 and you have a resistor R of 1 ohm. So say this is your V and this is your R. Now according to Ohm's law, V equals to I into R. So I will be equal to what? I will be equal to V divided by R. V is 5, R is 1, so I get 5 amps. So the current flowing here is 5 amps. This is 5 volts, this is your positive, this is your negative. So current moves from positive to negative. So it will go here, it will move here, it will move here, and finally it will return back. So I got my current. But since there is only one resistor involved here, I can directly replace this circuit, this whole circuit, from a voltage source to a current source as well. How much was the current? 5 amps. What was the resistance value? 1. What's the current flowing in this resistor? 5 amps. What's the current going out from the resistor also? 5 amps. Now, if I check the integrity of this circuit, I have a current source here having the same symbol, positive, negative, moving from positive to negative. So I have to check about the sign conversion as well. If this was negative positive, then this also will become negative positive. So the direction would be reversed. So the sign conversion and polarity is very, very important. Now, since we got 5 amps here, passing to this 1 ohm resistance. So what is the voltage across this 1 ohm resistance? Obviously, V equals to I into R. So V equals to what? 5 into 1. So V equals to what? 5 into 1, which again gives me 5 volts, which is basically this diagram back again. So if I want to convert from a voltage source to a current source or from a current source to a voltage source, it is easily possible, but provided there is only one resistor. But say suppose there is more than one resistor involved. So say I have R1, R2, R3 and R4. So there are totally 4 resistors involved. Then how can I effectively convert this voltage source to a current source? Now there are some criteria to this. Now source conversion is only possible if the voltage source is in series with one of the resistor and there should be no junction in between. It should be a direct series connection. So only if it is in series, the voltage source can be converted to a current source. So we will go through this step by step. So as I told you, it should satisfy the first criteria. That means the voltage source should be in series with the resistor. It means that, say you have a resistor here. Now, is source conversion possible? No, because the resistor is in parallel with the voltage source. So if the voltage source is in parallel with the resistor, I basically cannot convert it from a voltage source to a current source. But since it's in series, I can convert it. So first thing what you have to do is highlight the part that you are going to convert. So this will be my A and this will be my B. So basically I am taking out this circuit and converting it to a current source. So if I am converting it to a current source, now it follows the same rule and everything revolves under one basic law, that is Ohm's law. V equals to I into R. So say if I have Ohm's law which states that V equals to I into R, so I will be equal to V by R. Now what is the voltage here? 5 volts. So 5 volts. What is the resistor which is in series with the voltage source? 5 ohms. So my current will be 1 amp. So if my current is 1 amp, this will be my current source. Now the current source direction has to be taken as per your voltage source polarity. So if this is positive and this is negative, that means I can be sure that my current with regard to this voltage source is moving from positive and going to negative. So this is the direction from down to top. So this also will take the same direction. If this was reversed, then this arrow also would be reversed. So the current would move from up to down. So I have my 1 amp current source and your resistor should be taken in parallel to the current source. So this entire circuit is replaced by this. So this is my A and this is my B, and then everything else remains the same. So I effectively converted the circuit to a current source. So everything else remains the same, only that you have converted the voltage source to a current source. This is 5 volts. In the same way, the reverse is also true. If you can convert your voltage source to a current source, so your current source can also be converted to a voltage source. So now let's see how this conversion is possible. So if you want to convert this current source to a voltage source, again we go on Ohm's law, which states that V equals to I into R. What is my I? 1 amp into R, which is 5 ohms. So I get 5 volts. So that's why 5 volts again comes back. Again, the arrow is from down to top. So down will be negative, top will be positive, symbolizing the current flow from down to top. So once you got the voltage source here, this resistor which is in parallel to the current source has to be placed in series with the voltage source. So you have a 5 volt voltage source in series with the resistor. So there are two techniques involved here. The first technique is to convert from a voltage source to a current source, and the second technique is to convert from a current source to a voltage source. So the rules to be followed to convert from a voltage source to a current source is: first rule, if you are converting a voltage source to a current source, the resistor must be in series. If it's in series, then only you can proceed further. So that is your first step. It is satisfying. So then we can go to the second step. The second step states that if you have your voltage and that resistor in series, use Ohm's law, which is equals to V equals to I into R, and find the current. So I equals to V by R, so 5 by 5 gives us 1 amp. So we got a current source which is equals to 1 amp. And whatever resistor is there in series with the voltage source, you have to put it in parallel with the current source. So this is how your conversion can be done. But the converse is also true. So now we will go for the second technique, that is basically to convert from a current source to a voltage source. So in this process, there are also rules involved. The first rule, to convert from a current source to a voltage source. Now in the same way how we had to have the voltage source in series with the resistor to convert it to a current source, we should even have the current source in parallel to the resistor to convert it to a voltage source. So only if the current source is in parallel with the resistor, then only we can convert it to a voltage source. So if it is in series, we cannot convert. For example, if I had a resistor here, then in between this resistor and a current source, we have another resistor. So if we have another resistor here, the conversion cannot take place. So you have to have both the current source and the 5 ohm resistor in parallel to complete this problem. So once it's in parallel, we can convert it to a voltage source. So that's your first step. So the first step is satisfying. So yes, we can continue ahead. The second step, use Ohm's law to convert the current source to a voltage source. So again we go back to Ohm's law. Ohm's law states what? V equals to I into R. What is your I? 1 amp. What is your R? 5 ohms. So 1 into 5 gives us 5 volts. So now I got the value of my voltage source, which I put here. So then I converted my current source to a voltage source. Now what about this resistor? Now here my current source is in parallel with the resistor. So if I am converting the current source to a voltage source, this resistor has to come in series with the voltage source. So I have to take this parallel resistor and keep it in series with the voltage source. So I have my voltage source and the same value of resistor also will come here, only that I shifted it from parallel to series, and that's it. So if you are converting from a voltage source to a current source, the first point to remember is your voltage source should be in series with a resistor, which is this. Then only this conversion is possible. And if you are converting from a current source to a voltage source, my current source should be in parallel with the resistor. Only when these two things satisfy, then only source conversion is possible. If they do not satisfy, then we cannot use source conversion. Then we go for a method known as superposition theorem. Well, now we learned how to convert a voltage source to a current source and how to convert a current source to a voltage source. So how can we effectively use this in a problem? So now we'll see a problem where we basically utilize the property of voltage source to current source or current source to voltage source conversion and solve a problem. So we'll take a problem down. So now I basically have to find out the current flowing in this 3 ohms resistor or flowing through RL. So how can I find out my current? So the problem is, using source conversion technique, find out the current flowing in this 3 ohms resistor. Now, going back to the source conversion technique. Now, in the source conversion technique, we have learned that we can convert a voltage source to a current source if there is a resistor in series with the voltage source. If the resistor is in parallel with the voltage source, we cannot convert it to a current source. But if it's in series, we can convert it. And in the same way, we can convert a current source to a voltage source provided the resistor is in parallel with the current source. If it's in series, it cannot be converted to a voltage source. So the resistor has to be in parallel with the current source to convert it to a voltage source. So, using source conversion, now I basically want to find out my current flowing in this 3 ohms resistor. So now before we move forward, we have to see how many sources are connected in the circuit. So we have 2 sources. We have a voltage source of 6 volts and we have a current source of 3 amps connected in this circuit. And we have to find out the current flowing in this resistor of 3 ohms. So now if the current flowing in the 3 ohms resistor is known as IL, then I can even say the current flowing here is also IL. In the same way, the current flowing here is also IL. So if I know the current flowing in this resistor also, it is the same current. So if I know the current flowing in this resistor is IL, then definitely the current flowing in this resistance is also IL. Now, we basically have to find out the current flowing in this 3 ohms resistor. So now, if I want to use source conversion, I basically have to somehow combine both the current source and the voltage sources together so that I can find out my value of IL. Now, to do this, the first thing what we can see is we have a voltage source and we have a resistance in series. If you see this section, we have a voltage source and a resistance in series. So if the resistor is in series with the voltage source, I can definitely convert it to a current source through voltage source to current source conversion. So I am converting from a voltage to a current source. But if, however, as I told you earlier, if there was a resistor connected here, if there was one resistor connected here and then you had another resistor and so on, then you could not convert this voltage source to a current source. So it can only be converted to a current source if the voltage source is in series with the resistor. So if we have in between a resistor like this, we cannot use source conversion. So this is basically the only drawback of the conversion technique. In the same way, for your current source, if your current source is in parallel with a resistor, you can convert it to a voltage source. But if the current source is in series with a resistor, you cannot convert it to a voltage source. So coming back, now since the resistance is in series with the voltage source, I am converting this voltage source to a current source. Now, as I told you, to convert it to a voltage source, the formula we require is Ohm's law. V equals to I into R. So, I equals to V by R. So, now my V is how much? 6 volts. And my R1 is 3. So I have 6 divided by 3. which is 2. So I have I equals to 2 amps. So my current source will be equals to 2 amps. So I have my current source here. Now, as I told you, the resistor, if it's in series in the voltage source, it will become parallel in the current source. So whatever resistor value of R1 which is here, if it was series here, it will become parallel in my current source. And if I want to convert from current source to voltage source, the parallel becomes series. This is what we have already done last class. So I have 3 ohms here and this is my R1. The value is 2 amps, which I found out from this Ohm's law. The rest of the circuit remains the same. So you see, it is basically I am only cutting this circuit. If I call this as A and I call this as B, I basically now added this circuit here. So now I am adding this circuit back on. So what I did is I only changed this from a voltage source to a current source. So if you see, this is the change. What is basically done. So I converted this circuit to a current source. So I converted the voltage source to a current source using this logic. Now rest, once you converted it to a current source, the rest of the circuit remains the same. So I attach the rest of the circuit to this circuit here. So this is 6 ohms. This will be my R2. Then I have my R3, which is 2 ohms. And always make it a point to draw your whole circuit. Otherwise you may just end up skipping some parts, thereby making your answer wrong. So the rest of the circuit remains same. So this is my RL, which is 3 ohms. This is R4, which is 1 ohm, and this is IL. So I have 3 amps, 2 ohms, 1 ohm and 3 ohms. So the rest of the circuit remains same from these 2 points A and B. Now what else I can say about this circuit? I have effectively converted it to a current source. Now I got 2 current sources, but I still have a resistor in between. So I still cannot combine both these sources. So what else I can combine? I can combine these resistors together. So now you see, we are basically trying to make this circuit into a simplified or a condensed form, so that we can effectively find out the value of current in IL. So now I have converted it to a current source, but this resistor is in between. So I will simplify the circuit by combining the resistors together. So I will combine the resistors together and find out the value. So now, which resistors can I combine? As you see, R1 and R2 is in parallel. So now what I will do is I will combine R1 and R2 together. So if I combine R1 and R2 together, I get combining R1 and R2 together as RA. So RA will be equal to R1 into R2 divided by R1 plus R2. Now R1 is how much? 3 ohms. R2 is 6 divided by 3 plus 6. So I get 2 ohms. So now I found out the value of RA. So I effectively combine both these resistors R1 and R2 together to get one resistor value, that is Ra. So now again simplifying the circuit, so I have 2 amps here and I have my Ra, which is a combination of both these resistors in parallel, which I got as 2 ohms. So I found out the value of Ra. Now rest of the circuit remains the same. So from R3, which is equals to 2 ohms, amps and both my resistors of 1 ohm and RL, which is equals to 3 ohms. Yeah. This is my I. Okay, so now I effectively combine R1 and R2 to Ra. Now, once I combine this, what else can I do? I still have the R3 in between of both these current sources. So now I will convert this current source to a voltage source, because if I convert this current source to a voltage source, I will get this resistor in series, and then once it's in series I can add both these resistors. So that is my intention. So you have to always see one step ahead what it will do. Okay, so always check which resistors it can add in the future. So which resistors it can add later on, and thereby you can effectively combine or reduce the circuit into a simplified manner. So now I will convert this current source to a voltage source. Again, the rule for converting a current source to a voltage source. It can only use source conversion technique. Now, a current source can be converted to a voltage source only if, now coming to the rule of source conversion technique can be used for a current to a voltage source provided the current source has a resistor in parallel. So since the current source is in parallel with the resistor, we can convert it to a voltage source. So going on, a current source. Now you want to basically convert this current source to a voltage source. So again, V equals to I into R. Now I is how much? 2. R is how much? Which is basically your Ra is 2. So 2 2s are 4. So we got the voltage as 4 volts. So now again converting this current source to a voltage source. Now what is the current direction? In this way. So it is moving, current is moving from down to top. So when I am using my voltage source, my sign convention of my voltage source also will follow the same direction. Okay, so it will follow the same direction. So my current is basically moving from down to top. So my voltage source sign conversion will be positive and negative. The reason to this is, in a voltage source also the current moves from positive and goes to negative. So if the arrow is pointing up topwards, this is positive, this is negative. In the same way, this is positive, this is negative. Because current moves from positive to negative. So the same sign conversion the voltage source also will follow. And vice versa. If the arrow sign was down, then this would be negative and this would be positive. In the same way, this would be negative and this would be positive. So always remember, sign conversion plays a key factor here. So whichever direction the arrow follows, in that direction your positive will come and your negative also will come automatically. So you have to see which direction this current source has. So if the direction is moving from down to top, then your down will be negative and this will be positive. The direction in which your arrow points out is your positive, and where it starts from is your negative. So always remember that. In the same way, draw this. If you see the previous, also based on the same logic. So if this was positive and this is negative, my current is flowing from down to top. So I already got my arrow sign. This same arrow sign I have to incorporate here. So in whichever direction this arrow sign points out is my positive. It's pointing out to positive and it starts from negative. So always remember in which direction it points out. So this is how your polarities are basically given. So I got my positive and negative. Okay, so how much volts it is? 4 volts. So I'll write 4 volts. Now, what happens to this resistor? According to the rule, the resistor in parallel with the current source becomes in series with the voltage source. So I have a resistor known as RA right now in series with the voltage source. So I have 2 ohms here. I have R3 which is 2 ohms here. I have 3 amps. I have R4 and I have RL. So now again I have simplified my circuit. Now if you can see, there are 2 resistors, RA and R3. RA value is 2 ohms which I got here, and R3. Now RA and R3 are in series. So these 2 are in series. Now combining these 2 resistors into 1. So if I combine them, I call it as RB. Now RB will be equal to RA plus R3. RA is 2, R3 is 2, so I get 4 ohms. Now putting 4 ohms in my simplified diagram. So this is converted into just one resistor, that is RB, which is equals to 4 ohms. So I have 3 amps current source. I have an R4 of 1 ohm. I have RL of 3 ohms, and this is 4 volts. So positive and negative. So I have 4 ohms, I have 1 ohm, and I have 3 ohms. Now what else I can do? Now if you see, I have 4 volts here and I have 3 amps here. So now again I'll convert this voltage source to a current source. So if I convert this to a current source, this resistor will be in parallel, and then later on I can add both the current sources. So now again I'll convert this voltage source to a current source. So I'll rub this side. So converting the voltage source to a current source. Now, according to Ohm's law, we have I equals to V by R. V is 4 volts and your R here will be your RB, which is equals to 4. So 4 divided by 4 gives us 1 amp. So now my current source is basically of 1 amp. Again, as I told you, your polarity or what direction your current source will follow. The arrow is moving from down to top because current moves from positive to negative. So this will be the same direction my current source also will take. So since it's moving from positive to negative, the arrow is moving from down to top. So the current source also will take the same arrow, that is from down to top. So this will be positive, this will be negative. Now putting the 1 amp here. So I have 1 amp of current flowing in this current source. Now whatever resistance is in series with the voltage source becomes in parallel with the current source. So this is basically my conversion what I have performed. Rest of the circuit remains the same. So I have my 3 amps current source here, and I have my R4, which is 1 ohm, and my RL, which is equals to 3 ohms. So now what I see is I have 1 amp and I have 3 amps. Now if you notice, your 3 amps, your RB, which is equals to 4 ohms, and your 1 amp of current source. So your current source of 1 amp, 3 amps and your RB are all in parallel. So if they are all in parallel, I can basically shift this 3 amps current source here and I can shift this RB here because it is on a common bus bar. This is your common bus bar or this is your common node. So since it's on the same node, I can shift this here and I can shift this here. So modifying the expression, I can shift my current source of 3 amps to RB and I can shift my RB to the current source of 3 amps. So basically I can shift this current source here and I can shift my RB here since it's on a common bus bar platform. So redrawing my circuit, I have my 1 amp of current source, positive, negative. Then I have my 3 amps of current source also in the same direction. And I have my resistor RB, which is in parallel to the current sources, which is equals to 4 ohms, which is my RB. I have my RB of 4 ohms, which is in parallel with the current sources, and then the rest of the circuit as usual. So I have R4 of 1 ohm, and I have RL of 3 ohms. It's always important to keep drawing your figure, because when you draw your figure systematically, you will not forget any of the values. So even if it's a lengthy process, it's always advisable to redraw your circuit so that you don't miss out on any component. Now, if you see here, you have 1 amp of current source here, you have 3 amps of current source here. So, if this is my direction of my 1 amp and this is the direction of my 3 amps current source, my effective direction would be this. So, since this is a current source, it is supplying. It is using the same KCL logic, Kirchhoff's current source, Kirchhoff's current law. Now, Kirchhoff's current law states that the number of incoming currents is equal to the number of outgoing currents at that particular node. So, where is my node here? This is my node. A node is a point which is connected by 3 or more lines. So, a node is a point which is connected to 3 or more lines. Now, I have more than 3 lines connecting it, so that's why it's called a node. So what KCL states? KCL states number of incoming currents equals to number of outgoing currents. So which are the incoming currents at this node? So I have one current here and other current here. So this is incoming, this is going towards the node. And what is going away from the node is my other current. So this current here is going away from the node. Now, once we got the directions, we can use Kcl method. Now, Kcl is basically Kirchhoff's current law that states the number of incoming currents at a node is equal to the number of outgoing currents at that same node. So now if I consider this as my node, now a node is basically a point that is connected to 3 or more lines. So if there are 3 or more lines connected at that point, it is known as a node. So KCL states the number of incoming currents equals to the number of outgoing currents. Now which are the incoming currents? Your 1 amp and your 3 amp is your incoming current. That means it is moving towards the node. So anything that moves towards the node is known as incoming current. And that moves away from the node is known as outgoing current. So this is basically known as my outgoing current. So I have 2 incoming currents and 1 outgoing current. So KCL states number of incoming currents equals to the number of outgoing currents. So if I consider my incoming currents on one side and outgoing currents on one side, my incoming currents are 1 amp plus 3 amps equals to my outgoing current. What will be my outgoing current? 3 plus 1 is 4. So I got 4 amps of current. So if I name this as I1, my I1 will be equal to 4 amps according to KCL. So at any point, the number of incoming currents equals to the number of outgoing currents. Now I want to find out the total current. So basically I want the effective value of both these current sources. So the effective value of both these current sources will be equal to 4 amps. So I am using KCL and combining both of these current sources together. So if I combine them together, I will get my effective current source, which is equals to 4 amps. Since I1 equals to 4 amps. So this is my 4 amps of current. And everything else remains the same. So I have my RB, which is equals to 4 ohms. I have my R4, which is equals to 1 ohm. And I have my RL, which is equals to 3 ohms. So now I have 4 amps of current. So I basically combine both these current sources to give me one effective current source. So I used it using Kcl method, Kirchhoff's current law. Now say if this current source of 1 amp was in the reverse direction, that means the arrow is pointing from top to down. So the arrow here is basically reversed. Then the effective current in I1 will be 3 amps minus I1, because this will become an outgoing current when it is reversed. So it will be 3 minus 1, which will give us 2 amps of current in I1. So always check the directions and see which are your incoming and outgoing currents at that particular node. Now since both the current directions are from down to top, it is a cumulative. That means it's an addition of 3 plus 1, which is equals to 4 amps. So hence my I1 here will be equal to 4 amps. So this will be my effective current source value I1. So I replaced it with just one current source, that is 4 amps, which is 3 plus, which is basically 3 plus 1, which is 4. Now once this is done, if I want to find out the current IL flowing in this resistor, what will be the current here? Here also it will be IL. Here also it will be IL. Now these two resistors are in series. So the current flowing in this resistor R4 will also be equal to IL. So IL is flowing in this 4 ohms. So IL is flowing in R4 as well as RL. That means it's flowing in the 1 ohm resistor as well as the 3 ohm resistor. So if the value of IL is the same in R4 and RL, I can basically combine these two resistors together. So now combining both these resistors together, I get the rest of the circuit remains same, 4 amps. So I have 4 ohms, which is my RB, and now I am going to combine R4 and RL. So I'll call this as RC. So RC equals to R4 plus RL, since they are in series. So I have 1 plus 3, which is equals to So I have 1 plus 3, which is equals to 4 ohms. So I have a 4 ohms resistor connected in parallel with the RB. So my RC value will be equal to 4 ohms, which is a combination of both these resistors. Now I reduce the circuit to this variation. Now if you see, I basically have 2 resistors, RB and RC. So now let's get this circuit here. So this will be my RC, which is equals to 4 ohms. I have my RB, which is also equal to 4 ohms, and I have my current source, which is equals to 4 amps. Okay. So if I have 4 amps of current flowing here, so my current flowing here is also 4 amps. A resistor is not a supplying source, it is a draw. So 4 amps A part of 4 amps will flow here, a part of 4 amps will flow here, and finally 4 amps will return back to the circuit as well. So it has a go and return path. Now I will call this as IL, because anyways the current here is known as IL only, which is the current that we have to find out. And I name this current as I2. I have already named this current as 4 amps current as I1, so I'll name this as I2 and I'll name this as IL. So you see, again at this point, number of incoming currents equals to number of outgoing currents. Since this is the current source, this will be the incoming current and these will be the outgoing. And finally, again these currents, this will be IL and this will be I2. I2 plus IL will give me 4 amps. In the same way, 4 amps equals to I2 plus IL. So at both the nodes, you will get the same equation. So it follows current follows a go and return path. Now basically we have to find the value of IL. Now the value of IL can be found from current divider theorem. So from current divider theorem, IL will be equal to the main current flowing at the node. So I have two currents here, I2 and IL. I want to find out IL. So IL will be equal to the main current, that is 4 amps, which is my I1, into, now IL is flowing through the resistor RC. So we have to take the opposite resistor. In current divider theorem, we have to always take the opposite resistor. In voltage divider theorem, we have to take the same resistor pertaining to that voltage. But for current divider theorem, it is the opposite resistor. So if you want to find out the value of IL is representing which resistor? RC. So you have to take the opposite resistor. The opposite resistor is what? RB. I'll rub this out. So RB divided by combination of both the resistors. That means RB plus RC. In the same way, if you want to find out the value of I2 using current divider theorem, I2 is pertaining to which resistor? RB. So you have to take the opposite resistor. So if you want to find out I2 will be equal to main current, which is the same as you have for even IL, which is I1. So I2 will be equal to I1 into the opposite resistor. I2 is representing RB, so it will be into the opposite resistor. So I1 into RC divided by the combination of RB plus RC. So R2 will be equal to I1 into RC divided by RB plus RC, which is the same as per this, only that the resistor is shifted. So if you want to find out the value of I2, always remember you have to take the opposite resistor. Now coming back to IL. So now we can use this formula and find out the value of IL. Now the value of I1 is what? 4 amps. So I wrote the value of 4. RB value is 4. RB is also 4 again. RC is 4. Okay. So I have 16 divided by 8. So 8 divided by 16 is 2. So I have 2 amps of current flowing in IL. So this is how I can find out the value of my current flowing in my 3 ohms resistor. So I got the value of IL. So the current flowing in this 3 ohms resistor will be equal to 2 amps. Now I could have used current divider theorem and found out the value effectively. But if you notice, both these resistors are having the same value. That means there is 4 ohms of resistor here and there is 4 ohms of resistor here. So both the resistances are equal. Now if both the resistances are equal, the current also will be splitted equally. So when the current basically enters this point here, it will get divided equally across both these resistors. Why it will get divided equally across both these resistors? Because both the resistors are having the same value. So if there is 4 amps of current here, then the current will be splitted equally across both these resistors. That means 2 amps of current will flow in this resistor and 2 amps of current will flow in this resistor. Both combined, 2 plus 2 gives us 4. Number of incoming currents equals to number of outgoing currents. 4 equals to 2 plus 2, which is equals to 4. But however, if this was 4 ohms of resistance here and we had 8 ohms of resistance here, then majority of the current would flow in the 4 ohms and a part of the current would flow in the 8 ohms. So then there would be an indifference. But since RB equals to also 4 ohms and RC also equals to 4 ohms, then the current will basically split equally across both these resistors. So you have to see whether both the resistors are equal. So if both the resistors are equal, then you can directly say 4 amps divided by 2. So it will be, so another way to write this would be IL equals to main current, that is I1 divided by 2. I1 equals to how much? 4 divided by 2. So it will be equal to 2 amps. So this is how you can use this shortcut method and directly get your answer as 2 amps. But this is only possible if both the resistors are equal. So if both the resistors are equal, current will get splitted also equally across both these outgoing currents. So it will get splitted up as 2 and 2, which will give us a total value of 4 amps. So this is how you can effectively simplify and reduce your circuit and find out your current value using source conversion method.